All right, Gen Chem kids, we are going to start putting the electron configuration onto the periodic table so that hopefully we can see the pattern as it relates to the periodic table. So, the very first thing I want you to do is we are going to draw the dot pictures for the elements hydrogen, lithium, sodium, and potassium. We're going to go back and we're going to look at what we put for our dot pictures. Okay, for hydrogen, lithium, sodium, and potassium. So let's take a look. Okay, so potassium had one dot. Sodium had one dot right here. Lithium had one dot. And hydrogen also had one dot. So if we look at those, we can say that each of them had just one dot. Okay, so hydrogen's dot picture was like this. Lithium's dot picture was like this. Sodium's dot picture was like this. And potassium's dot picture was like that. So, what do hydrogen, lithium, and sodium all have in common? They are all in the first column of the periodic table. So if I look at the periodic table, I'm going to highlight this first column. We have all of those elements that we just talked about in this first column. So we have hydrogen that we were talking about, lithium, sodium, and potassium. So do you think the same pattern would be true for the rest of them? Rubidium and cesium and francium? Yeah, it is. That same pattern does hold out true. So this very first column right here, these guys all have one valence electron and only one. So if I want to label this, I'm going to label this, let's see. I'm just going to circle this 1, meaning that we have one valence electron here. Okay? So let's go back to our notes. Redraw the dot pictures for beryllium, magnesium, and calcium. So let's look at beryllium, magnesium, and calcium. So if I look for calcium, there's calcium. It's got 2. Beryllium, here we are. Beryllium is 2. I skipped magnesium somewhere along the way. Here's magnesium. Magnesium also has 2. So let's see. So beryllium had 2, magnesium had 2, and calcium had 2. Okay, so let's look at them on the periodic table. If we notice beryllium, magnesium, and calcium, they are all in the same column. So let's get another color. Actually, let's change it up so it's a little bit easier to differentiate. So do you think if we went on down to strontium and barium and radium that we would have the same pattern? We do. So each of these elements right here have 2 valence electrons. Okay, so I am going to do something right here. I'm going to mark that we have two. We have two valence electrons there. Okay, so notice our group numbers so far correspond with how many valence electrons we have in the outermost shell. Remember, a valence electron is the outermost shell. So let's go back to our notes. I want you to go back through your notes and draw the dot pictures for fluorine, chlorine, and bromine. Take a minute, pause the video. Okay, you ready to check? So fluorine, you should have 1, 2, 3, 4, 5, 6, 7 dots on fluorine. For chlorine, you should also have 7 dots. And for bromine, you should also have 7 dots. They're all the same when it comes to the valence electrons. So let's look at them on the periodic table. So fluorine, chlorine, and bromine are all over here, and they're all in that same column. So do you think the whole column has the same 7 valence electrons? If you do, you are right. Let's see if I can move this over. Okay. And I want to, let's move this out of the way so we can color this. Let's get another color. We'll do this one in green. So this whole column has 7 valence electrons. Now, the group number here isn't 7, it's 17. So when we look at our valence electrons, we're going to look at just the ones place here. So instead of 17, we're going to say 7 valence electrons. Okay, that should be VE with the dash for the electrons. Let's go back to our notes really quick. I want you to do the same thing for neon, argon, and krypton. Pause the video, take a second. Okay, so you ready to check? Neon, you should have 8 valence electrons. Argon, also 8. And krypton, also 8. Okay, so let's look at our periodic table. So notice we did not include helium with this. Okay, because helium has 2 valence electrons. So these guys all have 8 valence electrons. And notice the group number here is 18. So we have 8 valence electrons. Helium's kind of weird. Helium has 2 because let's put it in blue, symbolizing that it has 2. Okay, so helium has 2 just because it's because of quantum mechanics, and we're not going to go into quantum mechanics for you guys here. I want to put in a few more just so that you understand the valence electrons. We can label a few more here as well. So let's get yet another color. Let's use orange here. So this group right next to the halogens, oxygen on down, we can go down to selenium here. These guys have 6 valence electrons. So let's get an orange pen here for these guys. So we're going to label this with 6. Oh my gosh, that's really thick. I don't want it that thick. Let's 6 valence electrons here. And then let's choose yet another color. Let's do magenta. How about nitrogen and phosphorus? And sometimes arsenic, but we'll leave arsenic out for a second. These guys have 3 valence electrons. So if I change my color of my pencil to magenta, we're going to call this, or not 3 valence electrons. I am losing my mind. These are 5 valence electrons. And once again, notice that the ones place here tells us the amount of valence electrons. Okay? So we now, not the whole periodic table, but for a good part of the periodic table, we can actually assign how many valence electrons that these atoms are going to be using when they are binding to things. It also helps us kind of understand when we get to ions why different things have the charges that they do. So pay attention to the electrons here. All right, let's go back to our notes. So now knowing what we have on our periodic table, do you think that we could predict the dot pictures of rubidium, barium, acetylene, and radon? Let's look at rubidium. So if I look at the periodic table and I look for rubidium, I find rubidium right here. It's in that very first column. So I would expect rubidium to have 1 valence electron. So I'm going to put rubidium with 1 valence electron. Take some time, look for barium, acetylene, and radon, and tell me what you think. Pause the video and take a minute. Hey, you ready to check? Okay, barium, we are going to find right here. So barium should have 2 valence electrons. So you should have written barium with 2 valence electrons. Okay? And if I look for acetylene is down right here. So it's in the column that we labeled with 7 valence electrons. So you should have acetylene with 7 valence electrons. And radon is right next to it, 8 valence electrons. So you should have written radon with 8 valence electrons. How'd you do? Were you able to predict the valence structure for those atoms? Okay, now knowing the valence structure really helps us, especially when we start to formula write and figure out formulas. Okay, so members of this, oh my, that's not what I wanted to do. Members of the same group or family have similar chemical and physical properties. This was discovered by the Russian scientist Dmitry Mendeleev and led to the formation of the first modern periodic table. Okay, so if we think about that valence electron structure helps us determine similar properties, both chemically and physically. Dmitry Mendeleev made that periodic table in 1869 is when he published it. And he based that on similar properties, both chemical and physical. They didn't know electrons yet at that point, but he guessed that electron pattern right, and he got it. Okay, so what elements, let's go on. What elements would you feel would be similar to calcium? If I said that things in the same column, meaning the same valence structure, would be similar to calcium, we just need to find where calcium is and just list the elements in that column. So let's find where calcium is. So if I want to find calcium, I'm going to find it right here, and I'm going to change my color. Calcium's right here. Okay? So that means I would find that elements in this second column, beryllium, magnesium, calcium, strontium, barium, and radium, would all have very similar chemical properties and physical properties. So let's list them there. So I would expect beryllium, I would expect magnesium, and I would expect strontium and barium and radium to all have very similar chemical and physical properties to calcium. Okay? Oh, it looks like it skipped down on me. And what elements are similar to sulfur? So let's find sulfur. Right, sulfur. That orange is not going to show up on that sulfur. So let's do blue. Sulfur's right here. So I would expect oxygen and selenium, tellurium, and polonium to have very similar physical properties to sulfur. Okay, physical and chemical properties. So here for sulfur, I would expect oxygen, I would expect selenium, tellurium, and polonium to have similar properties to sulfur. Okay, take a minute and see what elements you feel would be similar to sodium and what elements would be similar to fluorine. Stop the video and take a minute. Okay, you ready to check? Okay, so for sodium,